everyone, welcome back to the React in-depth series. In this video, we're going to go over a bunch of exercises together to get more practice with data fetching in React together. In the previous video, we looked at some theory as to how data fetching works, as well as some examples. And I hinted at that this is one of those things that you really need to get a lot of practice with to really make sure that you have a good footing as to what goes on with the mounting and then the re-rendering of these components when you're actually doing data fetching and some of the issues that could arise as you're going through them. So in these examples, and exercises together, we're gonna go through a couple of those things that might pop up and some issues that we're gonna run into so you can get some real world practice, because this is very similar to what you'd actually be doing in your actual components if you're building larger applications or working on a team together. So let's take a look at these exercises. All right, so to start, as with all the previous videos, these are all up on the GitHub for the course. So that's in the description below. Feel free to grab it from there if you want to clone it down, or you can just pause the video and listen to the instructions and kind of go through it that way with me, whichever you prefer. So let's start with a warm-up exercise here. For this one, create a new React project. This is, I feel like I'm saying this over and over again, but hopefully if you're seeing this for the first time, this is the bundler that we've been using, as well as a few other tools that are built in, like the dev server. So go ahead and get that started. And we're going to be using the Pokemon API for this exercise, frankly, for pretty much all these exercises, since it's such a great API to test pretty complicated data that comes back. And it's quite fun because it has images in there. So you can visit that right here. In fact, I encourage you just to visit the API, and there's a documentation on there as to the different endpoints that we can actually use. We'll be using mainly the Pokemon endpoint, but for the last exercise, we'll be actually using a paginated endpoint. So I don't want to get too ahead of myself here, but hopefully you have a chance to read through that and see some examples. But we'll go through it together as well through this video. So once you have to take a look at those documentations, what we can do is create a Pokemon.jsx file and export a component of the same name. Then I want you to make it so that when the component mounts, right, this component called Pokemon, you fetch the data from for the Pokemon Squirtle. So Squirtle is a cute Pokemon, a water Pokemon, really, really adorable turtle looking Pokemon. So we're gonna fetch the data for Squirtle and display the following data for Squirtle: the name, which is Squirtle, of course, the image. You can choose any of the images. There's like sprites, there's like the fancier, like original images. There's all sorts of images on there. Pick whichever one you like, and then the weight of Squirtle. We can see how much Squirtle weighs. I don't actually know what the units are, but I just picked something random in there that is at the top level. So those are the data points we want to see. You can put them in any order and any type of tags you want, but we just want to display that onto the screen. And then import that Pokemon component into your main.jsx file, replace the app with it so it actually renders out, test it in the browser. And what you should see is all the data above for Squirtle after like a second or two, or maybe faster if you have a fast connection, from the API dynamically. And if you want to be bold, you can try different Pokemon names and then reload, and you should be able to see those as well. So give that a shot, and then we will go through it together. All right, so I'm going to open up my terminal here. I'll just run npm create vite at latest, and I'll get that going. I'm going to call this, let's do data fetching exercises. I'm going to make sure this is a React, and then a JavaScript. It's going to tell me the instructions to change the data fetching directory. I'm going to run npm install. While that's running, I'm going to open up the source folder here, have my exercises down here. I'll open up the main.jsx and I don't actually need the app in this case because I'm going to be creating a new folder for this. So I'm just going to get rid of this index.css. I don't need that in there. I don't want the styling from there. And I'm going to create a new folder here. And I'll call this Warmup just to put my file in, and I'll create a new file. I'll call this Pokemon.jsx. In here, I'll create a function, Pokemon, and I will export default Pokemon, and that's all great. And then we can actually get that started. So just to start, I'll just make sure that this actually works. I'll just say Warmup. And I'll go over to my main, and then I'll get rid of app there, and I'll import Pokemon from warmup Pokemon.jsx. And my npm install is done over here, so I'm going to run npm run dev now, and that should get my dev server started. And then I'm going to replace my app. Oops, that's not what I want. Public key credentials, absolutely not. I want Pokemon in there instead of app. And then that should be good. So I have my Pokemon. I should just say an H1 in there, and then I'm listing it as the only component inside my React app, which is wrapped in strict mode. So I'm going to copy this URL for my localhost dev testing server, and I'm going to go switch to Chrome, create a new tab. I'll paste that in there, and I should see my my warm-up, which is really nice. So there we go. I'll open my console, get that all started, and in my body there, I should see my H1 says warm-up, which is exactly what we'd expect to see. So that's great. So I'll close my dev server or my console there for that dev server on the right-hand side, so I have a bit more space. Switch back here. And actually, you know what? I'll switch back to warm-up real quick. I'm going to copy this data because that's what I want to pull out for name, image, and weight. And I'll go to Pokemon. And just at the top here, what I'll do is just so I don't forget, because, you know, short-term memory, I'll do this and I'll just say name, image, and weight. And I'm going to do this for Squirtle. There we go. All right. So now we are going to use the Pokemon API for this. So let's take a quick look at that. I'm going to go to Google and I'm going to search for Pokemon API. And I'll go to the first result there, pokeapi.co. I'll make sure I zoom in nicely. And we can see that if I scroll down here, we have some examples that we can play with. So here's like, if I switch this name at the end, this is Pokemon/Ditto. If I switch that to like, for example, Squirtle, make sure to spell it right, Squirtle, just like that. And I click submit. Down here, I should see the kind of results for Squirtle. So Squirtle has an ability torrent, and there's a whole bunch of abilities in there, forms, and height. We're looking for weight is right here. So that's 90 in whatever units that is a water type. So that makes sense. And we're going to get this information, but we need it in our React application. So this is the direct link to the results right here. So this is the API version 2/Pokemon/Squirtle. So I'm going to copy that. And I'm going to switch back to VS Code, and I'll say const URL is equal to that. Okay, so that is what I'm going to be fetching on mount. Okay, so now that I'm thinking on mount, well, that kind of leads me to think that I need a use effect. Because if I'm doing something on a mount condition and I'm reaching out to an API, that is a side effect. And I need an effect hook to do that, which is what the use effect is. So I'm going to pull that in, use effect. And when this component mounts, which means that I need a dependency of just an empty array here, which means please do something when this component actually mounts up. What are we going to do? Well, we need to fetch Squirtle and Squirtle's information from this API. So there's a few ways we can do this. We can create an async function in here. Remember, we can't do async here because useEffects can't return promises. They need to actually return the cleanup function. So what we can do is we can create an async function in here if you want, and then call that. I'll just do regular promises for now. But let's also think about something else we might need. So what I kind of want to do is let me kind of scaffold this out here. So I'm going to create a fragment, and in the fragment, I'm going to just put, I don't know, maybe I'll put like an H2, which is the name, and then below the name, I'll put maybe 2 paragraphs, and then one paragraph is going to have the, I think it was the weight, and then one will have the, what was it? The image. Oh, there you go. See, I already forgot. So it's not even a paragraph, it's an image tag. So I'll put an image tag here. And there we go. So we need a source for that image, and we need an alt for the accessibility and just screen readers and things like that. To just, or if it just doesn't show up for whatever reason because of network conditions. So we should provide those. So what are we going to do here? We need to fill this in with some kind of data that's going to come back from when we fetch from this URL. But when we first load this component, there's not going to be anything in here. It's going to be empty, right? It's only going to change after we make the fetch request. So we probably need some state so that this knows to re-render after the fetch request comes back. And we can actually fill that data in with whatever is in that JSON. So I'm going to create a use state. This is a pretty common kind of pattern of things that we're going to need. So I'm going to say const, and I'll say Pokemon and set Pokemon, and this is equal to use state. And to start, it's going to be null. Okay, so I could start to fill this in, but for now, let me just focus on actually fetching that data and then changing that state to see if it actually works. So I'm going to make a fetch request to that URL. And then the question is, do I need this URL out here, or can I put it in this effect? It doesn't really matter. In this case, I'm not actually using it outside of this effect, so maybe I'll just move it in here. That seems fine to me. Then I'm going to fetch that URL. This can give me a promise. And I know that this is going to be JSON, right? Like if we go back to our API, we're going to get back a JSON formatted response. So we know that from using the fetch API, we need to turn that into JSON with the helper function. So I'm going to say .then, we're going to get back the response, and I want to return the response.json. And once I have that, and I'll probably do it like this just so it's a bit easier to read, then I can do .then on that, and I'm going to get back the actual JSON. And then once I have the JSON, what do I want to do? Well, I want to set the Pokemon to that JSON. Okay, so let me go through this really quick, because this is really kind of the thing that we're going to do over and over and over again through these exercises. When the component mounts, we're going to fetch this URL. That's going to take some amount of seconds. When that completes, we're going to get back the response. The response needs to be turned into JSON because there could be other non-JSON types. So we need to tell it, hey, fetch, I know that this is like JSON parsable, and please turn it into JSON for me. Once you're done that, give it to me back as the actual string JSON, and then I can set the Pokemon to that object, basically, or that parsed object. So it's actually, sorry, not a string, it's an object, that JSON object that we get back as like a JavaScript object, right? JSON JavaScript object notation. So once this is complete, this entire chain is complete, Pokemon should be set to that actual value. So let's see if this even works. What I'm going to do is I'm going to put a console log here just outside of the use event in the main body of this function, and I'm going to log out Pokemon. Okay, and this is going to run on every single re-render, including the mount, and then including the re-render after this fetch request is complete. If I switch back to my Vite project here, I go to my console, we'll see that that's exactly what we see, right? We see first on mount 2 times because React mounts our components twice, and then we get back the actual JSON object, which is what we're looking for right here. So that's pretty nice. Let's look at that. We have our name in here, Squirtle. We have our weight, and we can get our images from the sprites in here. So if I open up images here, I'll do I don't know, I'll do front default right there. Why not? A sprites front default, nice easy one. Okay, so let's take a look at how we can do that. So once we have that going, we know that at the start, this is going to be null, but then eventually it's going to be that object. So let's see what happens if we do this. I'm going to say, I want the Pokemon.name, oh my gosh, in here, just like that, Pokemon.name. So if I switch back here and I reload the page, what we'll see is we'll actually see an error, right? Because when this component first mounts, we actually get null. So we're trying to do null.name. If you see this, cannot read properties of null reading name. So we're trying to do null.name, which makes sense, right? Like, well, it doesn't make sense because we shouldn't be doing that, but it makes sense that we're trying to do that because that's what we told JavaScript to do. We're trying to do null.name, right? Because that's what this starts off as. So we need to change this to be conditional only if there actually is a name there or an object there for the Pokemon, then we can render this out. So how can we do that? Well, we can probably do something like, for example, if Pokemon and this, so we could do something like that, which is saying if there is Pokemon at all, so if it's not null, then return this part right here. We could also optionally chain inside here. Maybe I'll do that for the next one, just so we can see another version of that. And now you can see if I refresh this page, even though it is null to start, we will actually see Squirtle pop up. And this Squirtle is not hard coded, right? This is coming from the API, which is coming from this key right here, right there, right name. Okay, so that's pretty nice. So the next one we need is the image. So image is going to be the source right here. So the source is going to be Pokemon. Let me switch back here to Chrome. We're going to do .sprites and then .front default. Pokemon.sprites.front default. That's where it's located. So Pokemon.sprites.front underscore default. And we know that this is again going to be null when it starts, right? So let me show you what I mean. I'll save this. I'll reload the page. We saw Squirtle for a split second. Reload the page. Again, can't read property of null, trying to read sprites. So we're trying to do null.sprites, which is what we're trying to do right here, which makes sense. So I'm just going to optionally change just so you can see a difference here. If there is a Pokemon, then grab the sprites and then the front default of that sprite. You could also add this here, not really necessary in this case, because if we have the Pokemon, it's probably likely that it'll have the front default of the sprites, but you can keep chaining it that way. And if I reload the page now, we'll see that we do indeed get that. For a split second, there's no image there, and then we actually get the image back from Squirtle. Look, Squirtle's so cute. Zoom in some more. There we go. Nice and big. Adorable. And the last thing we can do here is put the Pokemon Squirtle's, what was it? The height. Let's do that right in there. So same thing. And what we can do over here, let me just do the optional chaining just so you can see that in action differently from our H2. I can say Pokemon question mark if it exists dot wait, right? Otherwise, don't put anything in that paragraph. So notice that that's the 90 right there. For a split second, that paragraph is going to be empty. So let's see if actually this is going to reset if I reload the page, but it's going to be empty for a split second, and then it's going to come back in, and we'll see that wait in there for that 90. So it really depends what you want to happen. Like, do you want there to be a p tag that's empty? Do you want there not to be a p tag at all? Do you want to do this chaining, or do you want to do it this way? You can also extract this to a function to do it that way. There are many different ways you can actually approach this. I should definitely fill in this alt right here to be probably in this case something like the Pokemon name, just so that you can do something like this. Alt equals Pokemon.name. Probably not good to do this because if we don't have a Pokemon and it comes and there's an error, like this is probably not ideal. But for now, for this example, I think it's fine. What we'll see if I do that, if I come back to the Elements tab, you'll see that the alt tag here is Squirtle. We should probably do like Squirtle image or something, but I think Squirtle is fine for this example. All right, so there you have it, right? A couple different ways to actually get that working, and we have all of Squirtle's information in there, and that's going to happen on mount. That fetch request goes off, sets the state changes from null to the actual Pokemon object, and then we can re-render with all of this information conditionally rendered inside there. That's pretty nice. Hopefully that one makes sense for you. Let's take a look at exercise 1 together. Okay. So for this one, I'd like you to create a new project for Vite in React if you haven't already, or use the existing one. I'm going to use the existing one as I normally do, just to save some space and some time. We're going to use the Pokemon API again for this one. So that's this one right here. Take a look at the docs if you haven't taken a look already. Again, same thing, create a Pokemon.jsx file and export a component of the same name. Now for this one, almost the same, okay? But what I want you to do is I want you to make it so that when the component mounts, you're going to fetch the data for Pokemon named Mutin. Okay? I just made this up. This Pokemon, sadly, very sadly, doesn't exist. It's a great name. I should probably let Nintendo know that we should make a Pokemon named Mutin. I don't know what Mutin would look like. Maybe a cow-like Pokemon. But yeah, maybe we should start a petition to make Mutin, but it doesn't exist, sadly, for now. Very sad. So we're going to try to fetch Mutin. Mutin's not going to exist, so we're going to get back some kind of error. Okay, and we're going to try to display the name, the image, and the weight. So really what we're going to do is we're going to copy everything that we have from our warm-up. And if you don't have that, I'll just quickly explain it again and what we're going to see the issue is going to be. So again, note that this Pokemon does not exist, and we're going to use the same keys that we'd expect a real Pokemon to have, similar to the warm-up exercise, right? So when I say that, I mean that if you look at this, like these are the keys, right? Name, sprites, front default, weight, name, or if you use a different sprite or image, then you can use that same set of keys. Okay, so we'd pretending that this Pokemon does exist because all these Pokemons have the same format. But in this case, it's not going to exist. This is a fake Pokemon, unfortunately. So what I want you to do is figure out how would you deal with this error to display an error message to the user without crashing the app. So we don't want there to be console errors in this case. The user is not going to open the console. Imagine you're on a mobile phone or something, and you're trying to view this web page that you made, or you're showing it to a friend, right? We don't want them to have to be a developer to figure out how to use our application. They should have a nice, distinct error message. And it should be obvious that, maybe something's wrong. Maybe, that Pokemon was spelled incorrectly or something, whatever the error message is, but something visual that they can see. Okay. Once you have that, import it into your main, replace the app with it, test that it works. And to test it, you can test both Muton, right? And then a real Pokemon name like Charmander or even Squirtle from our previous example, and switch the name to make sure that it actually does work when you have a correct name. But when it is an incorrect name, you do see the error that you expect. Okay, so definitely more challenging. The error for this type of API, just a heads up, is not always a type of error that you would see for other APIs or other data sources, right? It's totally arbitrary. There are different patterns that different authors use when they create their APIs. Some are easier to understand, some are more harder to understand, some are just totally random. So take a look at what this error looks like and try to imagine, what do I need from the response to figure out if this is different from if I get the correct Pokemon back. Okay, so give that a shot and then we will go through it together. Okay, so I'm going to create a new folder here. I will do EX1. And I'll do the same thing. In fact, you know what I'll do is I normally don't like to do this, but I'm going to copy this Pokemon and I'm going to paste it, and I'll just explain it because we're going to make some minor changes here. Okay, so we're going to look instead for Muton. Then we're going to look for Charmander. But Muton to start. And we're going to grab Muton's name, image, and weight. So if you haven't seen this before and you skip this exercise, use effect to use state is what we're importing. We have state for the Pokemon object, and we have use effect running on mount with the URL. In this case, I'm going to switch this URL, and we're not looking for Squirrel anymore. We're looking for Muton, which doesn't exist. And we'll try Charmander later once we test that the error correctly comes through for Muton. And we're going to be fetching this URL, which doesn't exist. That Pokemon doesn't exist. We're going to see. We're going to try to turn it into JSON, and then we're going to try to set Pokemon to that value. Okay. Now this is a bit dangerous because we'd want to make sure that these steps work even in the case of an error, which we'll see probably might not be a good assumption, but we'll deal with that shortly. So this works, we know, for a correct Pokemon. Okay. Like if this was Charmander, you know what? Let's just put it for Charmander to start. And then we'll switch it to Muton after, and we'll see that it breaks. Then we have conditionally rendering here of the same stuff, the name of an in an H2, the source with it for the image tag, and then the P tag right here for the weight. Okay, so I'm going to go to my main.jsx. I'm going to get rid of this. I'm going to import Pokemon from my EX1 instead. .jsx right here, import Pokemon from EX1, not from the Warmup. I'll save that. I'll switch over here, and we can see that that actually works nicely for Charmander, right? We have Charmander, we have Charmander's image, and we have Charmander's weight. So I didn't code 85 anywhere in there, or this image anywhere in there. So that's working nicely. So that works. But now let's see what happens. If I switch back to VS Code and I go back to my EX1 Pokemon.jsx, and I switch this to Muton. This is not the correct Pokemon. So this doesn't exist. We're going to try to fetch something. The URL is correct. It's correctly formatted URL, but on their backend, it doesn't exist. We're going to try to turn that into JSON. We're going to try to set that JSON result to set Pokemon and then re-render with all the information. And we're just assuming that there's going to be a name. We're assuming there's going to be sprites. We're assuming there's going to be weight. Okay, so let's save that, and I'll switch back and let's see what happens. I'll refresh the page. Okay, so we get a blank screen. Okay, so usually that's a tell that something went wrong unless you purposely coded a blank screen. If we look in our root, we see that there's an empty image tag. There's an empty P tag. Okay, interesting. And if we go to our console, we have some errors. Okay, so let's look at these errors to start. So I actually have the console log from the mount and every other re-render in there. So we're seeing that we have null for our Pokemon. But then the error that we're getting, and I encourage everyone to spend some time reading these because it's very important. They look intimidating, what's very important is you'll see these errors repeatedly. We're seeing that we have a GET request to this URL, and we're getting back a 404. Okay, normally a 404, it means not found. Okay, that's the error for not found. Another tell here is that we are uncaught promise, syntax error, unexpected token n, not found, is not valid JSON. Okay, so it's basically saying that we made a request, we're trying to turn something to JSON, and it's saying, I don't know how to, I don't know how to do this. I don't know how to do JSON.parse of not found. I don't, like JavaScript doesn't know how to do that, right? Same error you can see, right? We can do JSON.parse of an object, but we can't do JSON.parse of this string not found, okay? So what this is telling me, and again, you wouldn't know this immediately unless you're having some experience dealing with these APIs before. But what's going on in my mind is that, okay, there's an error that happened. I'm trying to fetch something that doesn't exist, and I'm assuming that it's JSON. It's not JSON. So I'm probably getting back some kind of error and a string, or some kind of error message and an empty response. So my guess is, so this error is coming Pokemon JSX line 16. So line 16 for me is my fetch request. Okay, so my fetch, of course, is failing, and I'm trying to JSON parse it right here. This is response.json or JSON.parse, and that's failing, and that's why we're getting that error. Okay, it's a bit tricky to know that that's where it's failing, but let's take a look at how we can really tell for sure. If I switch to my network tab, what we will see is down here I have a 404. Let me see if I can make this a bit bigger. I have a 404 for Mutin, right? You can see that this was triggered on Pokemon JSX line 16, and it's a fetch request, and the status is not 200, which means success. The status is 404. So let me click on that, and that's going to give me some information. These are some important information that we can see. We'll get more experience with this as we build our own API in another series later on. But it's important to actually look at some tabs here. There's a preview tab. That's what would look like if it was HTML. It's blank, so there's nothing in there. And if there's JSON, we would actually see the JSON parsed out here. So there's no JSON or HTML in here. And if I look at the response, it looks like it's just not found, the text not found. Okay, so that's interesting. So if I look at the headers here, I can see that what are some interesting things I can probably tell that something's wrong? Well, there's a status code, and the status code is 404. And I can tell for sure that if it's 404, then that probably means that there's something went wrong, that it's not found. Or I can just use this not found. But it's probably better to use the status code to figure out that something broke. Okay, so that's kind of what I'm thinking. So let's go back here and let's think about this for a second. If this is not JSON, it's going to break. Okay, so I'm assuming that this response right here is JSON. So let's try to not assume that. I'm going to make this a function here, just like that, just so I can actually I can return response.json, just so that's the exact same code as it was before. I didn't really change anything. I just added the curly brackets and the return, which is exactly the same as a one-line fancy ES6 anonymous function return. Okay, so that's the same code. But now I want to log out the response. I'm going to say console.log of the response, okay, which is this response that comes back from this fetch. This is before we try to turn into JSON. This is just a raw response object. Okay, so I'm going to switch back to Chrome. I'll look at my console and I'll just refresh the page real quick, just so it's a bit higher up. And you can see that we have a response object here. And if I open that up, you can see that this response object has some a body in there, and there's some headers in there. There's an OK, which is false in this case. There's redirected. There's status text, and there's some other things. So sometimes you'll see that we can use OK, we can use status. If I go to Google here and I search response JavaScript, maybe I can look at that API right here. So on MDN for response web API, if I zoom in here, you can see that this is an interface for the fetch API, represents the response to a request. So you can see that there's a lot of properties on here: body used, headers, OK. OK is a indicates whether the response was successful, which means that the status was in the range 200 to 299. So we can use that, which means that something is good. Response.status is what we just saw. Status code of the response, this will be 200 for a success. So there's many different options we can use, right? Let's just use response.ok for now, because that's a simple Boolean check, but maybe we want to do different types of errors. If there's like something like a 404, 403 or 404, we could use something like status or status text. So it's really important to know these APIs, and we'll dive deeper into these in future videos, when especially we actually build our own APIs from scratch. So I want to check here, was the response okay? That's what I want to do. And only if it was okay, then return the JSON, because that means I actually got something back. So I'll say, if the response.ok property is false, then that means that there was an error. Okay. And I want to like return, in this case, early, or change something and then return early, so that I don't try to go to the rest of this code, because it's going to break. All right, so what am I going to do? Well, one thing we can do, and this is pretty common, there are many strategies for this, and by no means this is the only way to do this, and this is true for all the exercises. I'll go with the simplest kind of route of no resistance, just so you can see one potential solution. I'm going to say const error set error equal use state. I'm going to create a null error state. So by default, there is no error, which makes sense. Okay. And here what I can say is, if the response was not okay, well, I'm going to say, well, there is an error. Set error to be true. Okay. That's going to be the new value of error. Okay. We can even put this to false if you like to start. Doesn't really matter. Okay. Now, what that's going to do is we're going to have a way to test if there was actually an error, and we can actually return a different value depending on if there was an error or not. So we can use this to trigger like a different type of render conditionally if there was an error. Also, we don't want to go to the rest of this code, so I will actually just return out of this and make sure I don't actually go to the rest of this function. Okay. Okay, so this might cause an issue, but we'll look at that shortly. So if I refresh this page, what we'll see is we get back a what is it called, a 404, and if we look at this response, we see that OK is false, and now we're getting undefined on line 31. So let's take a look at what that is. Line 31, that is Pokemon. So Pokemon is undefined, and that's because we're doing .then of JSON set Pokemon of JSON, which is going to be undefined because we're returning undefined in this case. Okay, so this is a bit dangerous. The reason is that maybe we have other things here in our chain of promises that would break if JSON was undefined. Okay, so that's why I'm not really particularly happy with this solution, but it is one solution and probably the path of least resistance if you're doing this for the first time. So I'll leave this in here. One way that we could actually not go through the rest of this is we could like throw an error, or we could return a different type of object, and we could test for that object down here. There's many different solutions that we can use, but for now I'm just going to return so that we don't go to try to JSON stringify it. We're going to just return undefined here, and we're actually going to come down here. You could also, in this case, if you want to be really simple, you could just return an empty object, for example, which just shows that there's nothing in there. I, again, don't really like this solution, but I want to focus on the error state for now, just so that we can actually get that working, and then we can think of some strategies for the other one, and I can let you try to implement them, or we can discuss them further. So once we have error to be true, that's the main point. If the response was not okay, set the error and then just return. Okay, don't try to turn into JSON, and in this case, it is setting it to be undefined, which we just discussed. So if error is true, what do I want to do? Well, let's think about this. We could actually come down here, and I can say, well, okay, if there's an error, then also check the error, Pokemon and error, or image and error. We could do all of that. Or what I can do is I can just do something as simple as this. So check this out. This is kind of what I wanted to show you. If there's an error, I just simply want to return a p tag that says, sorry, something went wrong. Okay. Of course, you would want a better error message than this. Normally what happens is the response object you would get back would actually have an error in there. So instead of just setting error to be true, you would set it to be whatever came back in that response. There's many different APIs that actually would give you back a valid, so it would be okay, you get back a 200, but then this object would actually have the error object inside of it instead of the other data. So it's a bit tricky to explain every single possible solution that you'll need to see, because it depends on the API that you're using. So really watch out for how the message gets formatted back from the actual API. So that's why we went through the time to look at these requests. This was a 404. It was not sending back JSON. It was not sending back HTML. It was sending back plain text with a 404 status and the response OK toggled off. All other APIs might send back a 200 request. Response is OK, that's true. But then there's an error object instead of the actual Pokemon, like in this case. Okay, so it really depends on the actual API you're using. So back to this. What we have is right before our regular JSX, we're saying if there's an error, return that something went wrong. Otherwise, return the regular JSX that we expect. In a lot of programming, this is something called a guard function, okay, or just a guard in general. It's not really a function. In this case, it's just a guard. We're guarding whatever comes after this, and everything after this can be certain that error is false. Okay, so if error is false, that means that response was okay, which means that we can go ahead and render all this out. Okay, maybe there are other errors we need to check, but for this basic example, this is good enough. So if I come back here and I reload the page, what we'll see is that we're still making a 404 request out to that API, but we're not getting anything crash. We still come back to our Elements tab. We have the correct p tag in here, which is sorry, something went wrong. So this error message should probably be better formatted, and we could do that depending on, for example, if there's a 404, right? Then we could say, if there's an error in this case, we could say, sorry, Pokemon name must be valid or something, right? Like that. And that's a bit better. You can probably get much more granular with these errors, but you can probably see where that's going. Okay, much nicer than just seeing a blank screen. Your user wouldn't have to actually open up the console tab or open up the network tag and filter through there to figure out what's wrong. This is much clearer, and we can be guaranteed that we can't get past this guard unless there's no errors in our code. All right. Now, again, there are many other solutions to this. This is a bit of a sloppy solution. I really wanted to show you that you can do tests like this in here, and then you can guard the JSX that gets returned. I would encourage you to try some other solutions. You can look at the status. You can try throwing an error. You can try different solutions or returning an object and seeing all those different solutions that exist, and see which one you like for this particular case. And then other APIs might behave slightly differently. Okay, so that was a lot of yapping, but hopefully that helped a little bit. Errors are definitely one of those things that is quite challenging to deal with, and every single situation is unique, and you want to spend the time making sure that you are thoroughly testing the errors that come back, and even styling them, in this case, probably styling it nice and red, just so it's very obvious to the user that maybe they can try sometime later or something that they did was incorrect. If I change this back to Charmander, we can prove that if I reload this page, we can see that Charmander does indeed render correctly because response.ok is true, and we pass that test, and then we do the rest of the return the JSON correctly. Okay, and if we switch this back to Muton, cute name, but doesn't exist. Sorry, the Pokemon name must be valid. Okie dokes, there we go. Hopefully that one makes sense. Let's take a look at exercise 2. All right, so for this one, same thing. I'd like you to create a new React project. Use the Pokemon API again for this one. Create a Pokemon.jsx file, export the component of the same name, and have Pokemon, in this case, return an input tag for text, so input type text, as well as a button to click to search for a Pokemon. So make it so that when you can enter any Pokemon name inside that, that input text, and click the button to search for it, and the Pokemon API and display that Pokemon's name, weight, and image, just like we saw previously. So this is a dynamic version of the warm-up as well as exercise 1. So you want to make sure to handle the error case. So if we try to look up something that doesn't exist, the other thing we want to do in this case, and this is definitely quite challenging, is if you search for the same Pokemon again, I want you to find a way to cache that data from the previous request. Okay, what that means is if the Pokemon has already been searched, we don't want to make another request for that Pokemon. We can store the responses, the JSON responses for previously searched Pokemon so that we don't need to make another request in the future for that same Pokemon. We can instantly show that result. So the way that you can do this is you can use a JavaScript map or an object to store these JSON values. If you don't know much about how a map works or objects, take a look at the JavaScript series. We go through those in quite a lot of depth so you can have an idea of specifically this use case of caching. And I would encourage you to use a map instead of an object, just so you get used to that API, since that's most common for these kinds of tasks. So the steps you want to do are check to see if the cache has a Pokemon already that we've searched for. This is every time we do a fetch request. If not, make the fetch request and store it in the cache, which is the map or the object. And if it does, return directly from that object or map without making the request. Okay, so only make a request the first time that Pokemon is being searched. If it's being searched again, return that Pokemon immediately from the cache without making another network request for all subsequent requests for the same Pokemon name. Okay, so definitely quite challenging, and we'll see in future videos how we can make this even nicer by using things like custom hooks. Then I want you to do the same thing, import that into main, replace the app with it, and test that it works in your browser. Try the same name twice, check the network tab for duplicate requests, also test the error case. So if you search, for example, Pikachu, it's going to make a network request for Pikachu, but if you search for Pikachu again, you should not see another request for Pikachu. Okay, you should only see that first one. All right, so definitely quite challenging. Give it your best shot, and then we will go through it together. Okay, I'm excited for this one. A lot of fun. I love caching problems. Okay, let's do EX2. Same thing, Pokemon.jsx function Pokemon. And what I'll do is, I'll just do this from scratch. So we know we need a use effect and we need a use state. So we're going to do use effect and we need a use state. All right. So I'm going to do a use effect, and this is going to run on mount. And we're going to do something in here. And we're also going to do state. So we're going to say, in this case, const, we're going to say, I guess, I guess the question is like, do we really need the state? And that is something we can discuss shortly. Pokemon, but we'll do set Pokemon just so that we can start somewhere with something. We're going to start off with null. And then we're going to return some JSX down here. I'm actually going to copy the JSX so you don't have to watch me do this over and over again, because it's actually pretty hopefully you can find this not that interesting. I'll just go over this really quick. This is from exercise 1, same JSX, nothing different here. This is the returning JSX fragment. Is Pokemon true? Or does Pokemon exist? Sorry, is it not null? Then the H1 with the Pokemon name in it. Image tag with the Pokemon. We're using what is it called? Conditional chaining, optional chaining here. If Pokemon is not null, grab the sprites property, grab the front default property, put that in source. Same for the alt tag Pokemon.name. And then for the p tag, grab the Pokemon weight using optional chaining as well. Okay, so that's same as the previous exercises. And if you're jumping into this exercise for the first time, hopefully that one makes sense to you. We're just conditionally rendering depending on what is happening in there. Okay. So we haven't set this yet, so we need to figure out how to set the Pokemon. And we also don't have a cache. So let's think about this. When the component mounts, we need to fetch that Pokemon, but I also am missing an input and a button. So let me add that here. So I'm going to say an input, type text, and then I'm going to say a button. Button is going to say search. Okay, you can put whatever you want in this button, doesn't really matter. And then when we search, we're going to do something. So what are we going to do? Well, we're going to search for the Pokemon that's inside of this input. Now, I know that I want access to this input. I don't want to do a whole bunch of fiddly stuff with query selector because we want to do this the React way. So I'm actually going to grab use ref to stick a ref onto this DOM node so that I can grab the data inside of there. So ref, or I could use state. It doesn't really matter that much what you're doing. You can do both ways. I'll just show you the use ref way just so you can see one potential solution. So I'm going to say const input ref is equal to use ref, and this is going to start off as null, and then we're going to set the ref to be input ref here just so I have access to this input. You'll see why in a second. When I click the button, I'm going to do the search Pokemon. I'll call it that. And I'm going to create that function. I don't think do I need the use effect? I actually don't know. We'll see. Function search Pokemon. And this is going to do something. What is that something? Well, we are going to grab the ref's current value. And you could do this again, as I mentioned before, with state. So we could have made this like a controlled input and just hooked up a bunch of state to it. That's probably a better solution in this case. I just wanted to show you that you could also do it with ref. And then you can kind of clear off that input using that ref as well. Different options. I actually don't know what's better in this scenario, probably the controlled input, but we'll see as we go how we can do it in different ways if we run into some issues. So when we search for Pokemon, so what are we going to do? Well, I'm going to come back here and I'm going to copy. I guess first is we're going to, does the Pokemon exist in our cache? That's step one. If it does, return it. Otherwise, fetch it, set Pokemon, and put it in the cache for next time. Okay, so let's figure out how we're going to do this. We don't have a cache currently. We probably can do this with a ref because we don't want to cause re-renders based on what's in our cache. We want to control the renders based only on searching for the Pokemon. So I'm going to create another ref. So I'm going to say const Pokemon cache is equal to use ref. And this is a great example of where you would want to create a reference with not for a DOM node. And what we'd probably want to do in here is create a new map. So usually what you could do is you could probably create this map outside the function scope because creating a map is not particularly resource intensive, but this is actually going to, I believe this is going to execute every single time, even though the ref is going to stay the same. So what you could probably say is like const Pokemon or like const cache is equal to a new map out here, and you can just put the cache in here. Or you could just do it like this since this is not particularly resource intensive. It really is up to you. You'll see both. I'm not really sure which one I'm a fan of. This is definitely the safer option though. Okay, so we'll stick with that. Pokemon cache is a new map. And what we want to do then is we want to check to see if it exists in this cache. So we need access to the Pokemon that we're searching for. So we'll say if ref input ref, or in this case, input ref dot current dot value. So remember, the current is the node or the property on input ref that automatically stores the reference for this for this DOM node, and then the value property is just what's in that input in the case of an input node. So if its value, so as I'm typing in there, which is the name, is in our cache. So how do we do that? Well, we can use the API for a map to figure out if something is a key is in there. So I can say if Pokemon cache dot has this input ref dot value, then that means that Pokemon is in the cache. Okay, so that means that it's in there. Otherwise, not in the cache. right? And we probably could get rid of the else, and we could just early return. We could do various things, but let's stick with that for now. So step 1 is complete. Does the Pokemon exist in our cache? We've done that. If it does, return it. So if it is in there, then we want to return it. So how do we return it? Well, now we're going to be using this value multiple times. So I'm going to actually grab that and store it out here. I'm going to say const Pokemon name is equal to that input ref.current.value Pokemon name. I'm going to put that there. Okay, because I'm going to use it again. I want to keep typing that over and over again, and that's a nice way to refactor as you're going. If it has it, then I want to say we're gonna grab it from that cache, and we're gonna set it to be that Pokemon, and we're not gonna make a fetch request. So I'm gonna say set Pokemon to be Pokemon cache dot get. I think it's get. Is it get? I always forget. Let's check. So we go to Google and we'll say map JavaScript. You can see I always forget what these are. We don't want array prototype map. We want map, the actual object from JavaScript. And we can see that we can set and we can delete and we can get. So it is get, right? So hopefully you can see that one there. We can set values and then we can get values, and we can check the size and we can delete values. And I think they don't have a has in here, but has, if we scroll down right here, is right there. That's the has that I was using earlier. Okay, .get, what are we getting? Well, we're getting the Pokemon name, and that's all we need to do. And then, technically we can just return, and then I can get rid of this else now, because I know that I'm not going to be, I'm going to exit the function right away. Okay, just so I don't have to have nested code. I'm trying to avoid a nested code as much as possible. This is almost like a guard condition. Okay, so that's great. We could put this in one line if you want to be really fancy and say return that, because we're not really using the return value in this case. So now, if it is not in the cache, well, this is where things get interesting. Well, if it's not in the cache, what do we have to do? Well, we need to fetch it, and then we got to set the Pokemon to be that Pokemon that's being fetched and put it in the cache for the next time. Okay, so now this is where we have to do a couple things, because it's not as simple as just getting that Pokemon, because we also have an error case. So we're going to say fetch, and we have the URL for that Pokemon. So if I come back here and I go to the Pokemon API, I'm going to copy this URL here, direct results to, or you can copy it here this way as well. And I'm going to make this a template string. I'm going to paste that in there. And instead of Squirtle, I'm going to get rid of Squirtle, and I'm going to template in whatever the actual name is from that ref. Okay, so that's the Pokemon name. Pokemon name. All right, so there we go. So we're going to search for that. Now, there's a couple of things that could happen here, and we just saw with the error case. So we're going to get .then, we're going to get a response, and our response can not be okay. So we'll say if our response is not okay, then we have an error. So there's a lot going on here. Otherwise, we're okay. So the error case is the case where let's create another state here, just like we did in our previous exercise. Const error set error. This is going to be equal to use state. We'll start it off as null. And just so we don't forget here, right below here, right above where we create our JSX for the non-error case, we're going to say if there's an error, we're going to return, let's do a p tag, sorry, that Pokemon doesn't exist. Okay, so that handles that case. So we gotta actually do this. So we're gonna say set error to be true. We can set Pokemon to be nothing, but that's not gonna do anything in this case. And we can just return for now. We'll just go with the simple case of returning undefined. Okay, so if the response is okay, we want to return the response.json for the next part of this fetch. And then we're going to do .then, and we're going to get the JSON, and we're going to set Pokemon to be that JSON. But in this case, actually, what we're going to do is a bit more. So I'm just going to get rid of that really quick because it's not as simple as that. We get back the JSON. We need to set Pokemon to be that JSON. However, we also need to set our cache to have that value inside of it, because we need a way so that when we come up here in the future, we can eventually, if we search for that Pokemon 2 times in a row, it is in that cache. So we're trying to see if it's in there. So we need a place where we're actually inserting it into that cache, so that if it's been searched before, we come into this case and we don't have to do all this fetching again. That's the whole point of this exercise. So I want to, in here, put it in the cache. So I'm going to say Pokemon cache dot set, and this is going to be the Pokemon name. So this is the key, and the value is going to be the JSON. Okay, so it's going to be like Pikachu, and then the entire object for Pikachu. It's going to be Charmander, and the entire object for Charmander. Okay. Now, there are some bugs here, because what's going to happen is we're actually returning undefined. So that might be a potential issue, and I'll let you think of why that might be a potential issue if we're doing it this way, because we might be setting the cache up in certain cases if we do that. Okay, so this is an example of where we want to be a bit more careful with this. But I want to just get this working so we can actually see results on the screen, and you're not watching me type code for too long, because the core of this loop is correct, right? We want to when we search Pokemon, we want to grab that Pokemon name, check if it's in the cache. If it is in the cache, we want to set to that Pokemon right away, and then we want to return. We don't want to make a request, okay, because it's already been searched and it's already been stored in there. If it's not in the cache, we need to make a request to that Pokemon. We can then grab that response, check if the response is okay, set the error message to be true if it's not okay. Otherwise, we return the JSON of that Pokemon. Then we can set that Pokemon's JSON so it can be displayed right away. And then we can also set the cache so in the future, if it's in there, we can, and we search it again, we don't make that network request, because then this part up here is going to be true. Okay, so that was a lot. Let's see if this actually works. I think we are good for the most part. I just didn't clear my input, but we can do that after. So I think that should be fine. Let's just see if this works. It turns out we didn't need our use effect because everything is based on the search Pokemon function. You don't know if these things work until you actually try them a lot of time. So I'm gonna make sure I actually export this at the bottom. Export default Pokemon. That's probably one of the more important steps. I'll save that. And I'll switch to my main, and I'll comment that one out, and I'll say Pokemon from our EX2. Sorry, this is going a bit long, but I really want to make sure we spend a bit more time on data fetching. And there we go. So let's switch back to Vite. So far, so good. I'm going to search for Pikachu. I'm going to click search, fingers crossed. We get an error. Okay. Pokemon.cache has is not a function. Why is that not a function? That's not the error I was expecting, but this is fun debugging. So let's go back to my EX2 Pokemon cache dot has, and that's because it is a ref. All right, so common mistake here. Remember that the properties get set on the current value if we're using a ref. So we're not actually setting a Pokemon up to be an object directly. This is a reference. If we had our Pokemon cache out here, then we could have done Pokemon cache dot what was it, has and get and all that kind of stuff right away. But since it's here, it's on the current property. So everywhere I'm using Pokemon cache, this is kind of annoying. I would probably just try to grab this out of and like grab the name out of this. So I could say like Pokemon cache is equal to Pokemon cache.current or something. But I'll just replace it for now, just so you can see how annoying that is. And then we'll go with that. So we're grabbing the current property and then .has current property .get. And then down here, this is the current property. This is not the solution I would go for, but we would probably refactor that along with refactoring this right here as well later on. So let me refresh that. We'll try it again. Pikachu, fingers crossed, search. Look at that. So I'm surprised that worked. There's no errors beyond that error right there. So Pikachu works. Let me search for Charmander. And I'll do search. Charmander works. I'll search for Charmander with 2 R's. Let's see what happens. Search. And I get, sorry, that Pokemon doesn't exist. Interesting. Okay. So that's pretty good. That's pretty much what we wanted, but our entire screen disappeared. So that's totally fine, right? What we can probably do is switch this to be like a conditional render. So that's one of the issues with doing it this way, is we're replacing the entire DOM with this value instead of allowing the user to keep typing and searching, right? So what I would probably do is not this right here. I would say like, I'd probably put here and right below the button, I'd say if error is true, then I want to return this right here. There we go. And I think the rest should be okay, because those are all still conditionally rendered. And I'll just comment this out. Let's test that and see if that works. Will that work? Actually, my brain is kind of shutting down. Let's try this. So I'm going to search for Mew. Search Mew works. I'll search for Mew, 2 W's, and we get sorry, that Pokemon doesn't exist. So that works nicely. And I go back to searching for Mew, and we get Mew show up. So actually, that's what I want to show is you saw that came right away. Let me refresh this, because this is the part I want to show you. So that conditional rendering part actually works because we actually properly set up the conditional rendering for this to make sure that Pokemon does exist. Otherwise, it's not actually going to render keys that are not there. So that part works fine. In this case, I would not conditionally render it like this. I would want to make sure that the user can still try and type in there. We also should clear the input here somewhere. So I'll leave that as an exercise for you, depending on where the correct case is, so you don't have to keep retyping. But what I want to show you in the point of this exercise is the caching. So I'm going to switch to the network tab, and I'm going to clear the network. I'm going to search for one of my favorite Pokemons, Mankey. Okay, I'm going to click on search. I reloaded the page. I've never searched for Mankey before. I'm going to click on search, and I expect there to be a network request for Mankey. I'm going to click search, and there it is. There's our network request for Mankey. It took however long that is, right? However many milliseconds, what is that? 400 milliseconds or whatever that is. I don't know why it's so small. I think I'm super zoomed in. So that request is there. One request and another request for that image. Now, if I click search again, I don't want there to be another request. Let's see what happens. I click search, no request. So to prove to you that we're not making a request, I'm gonna try something. I'm gonna switch this to Mew. I'm gonna do a search, and we see a request for Mew go out as well as Mew's image. I'm gonna go back and I'm gonna change this to Mankey. And I'm gonna click search, and we're not gonna see Mankey. We're gonna see the fetch request for Mankey. We're gonna see Mankey show up right away. 1, 2, 3. There it is. Mankey's right away. There was a fetch request again for the image URL, but that was cached by the browser automatically, so we don't have to worry about that part. The actual fetch request you can see is not being made. So that is super awesome. If I search for Mew again, we'll see that is cached as well. So that's pretty awesome, right? That's called the cache hit. So in this case, where we see it in the cache, this would be a cache hit. So we hit the cache, we're really good. That's a super good scenario. And this would be a cache miss right here. If it's not in the cache, pretty much all this stuff here, this is a cache miss. And there's many strategies to deal with this. A lot of libraries do this behind the scenes automatically, as I mentioned in the previous video when we're looking at some of this stuff. But hopefully that one makes sense. There was a lot going on in this case. Definitely not the best solution, just one very quick hacky solution to actually go through this stuff. There's a lot of improvements that we could make. For example, the error condition we could improve. We could clear the ref. As I mentioned, this returning undefined here is kind of an issue. There are a few other tweaks that we could probably make to make this quite nice. But overall, the entire point of this was a caching idea and handling a bit of the error as well, just like the previous exercise. So hopefully that one makes sense. I highly encourage you to really make sure that this part makes sense to you, because that is so critical to understanding how front ends communicate with other systems, like in this case a REST API, and kind of different types of errors that you might see, and how the actual like waterfall of network requests actually works behind the scenes. And you can use these wonderful browser developer tools to actually get that working. Okay, and I'll end this by searching for Mewtwo spelled wrong with a 2, and then I will see that I am searching for Mewtwo, but that Pokemon doesn't exist. And if I go back to searching for just Mew, I do indeed get Mew cached. But I'm still not clearing this, so that's actually a bug there. We have to get rid of that. So another little bug that I discovered, but we should probably move on to an exercise. I'll leave that as an exercise for you. We forgot to actually switch to setting the error condition true. Try to see where in the code you would actually switch that back to be false. Okay. Wow, this one's going long, but I'm excited to show that to you. This is a super important topic, so hopefully you're bearing with me as we go through these exercises. Let's take a look at the last one together to wrap up this video. This is also going to take a little bit of time. Okay, so for the final exercise, I want you to create a new project or use the existing one. We're going to use the Pokemon API again for this one. Look at the docs. This time I want you to look at the pagination section. I'll go through it with you, but look at the actual docs tab. I think it's called V2 or something, and look for something called pagination. I think they call it one more thing beside there, and read through how it works. We're going to be fetching pages of Pokemon this time, which is a pretty common task for fetching pages of information at a time. Then again, create a Pokemon.jsx file and export a component of the same name. Now, here is the crux of this exercise. I want you to make it so when the component mounts, you're going to fetch the first page of Pokemon. Okay, so by default, the limit is 20 and the offset, as I call it, is 0. So I'll show you what this means as we look at the API, but that's kind of the default. So use the defaults that they give you in the examples. So we're fetching 20 at a time. Then I want you to create a list of p tags, each with a Pokemon name from the return list to put in the JSX markup. Okay. This will be returned at the top of the return JSX, and there's going to be some buttons below it, which I'm going to mention in a second. Okay, so we're going to have basically up to 20 p tags at the top of our DOM with 20 different Pokemon that are coming back pages at a time as we click on them. Okay, so there's a maximum of 20 at a time. Now, below that list of 20 potential p tags, we're going to have 2 button elements in the same Pokemon component. And one is going to say previous, the text previous in it, and the other is going to say the text next. Okay. I want you to put these at the bottom of the JSX and have their on-click fetch either the next or the previous page of Pokemon, depending on which button's clicked. And it's going to re-render the list of p tags with the new set of names. Okay. So I'll put that in hopefully a bit more clear terms. We're going to have a list of Pokemon at the top, up to 20. There's going to be 2 buttons on the bottom, next and previous. When you click previous, it's going to fetch the next list of 20 names and display those. And you're just going to keep doing that. Right? You click next, next 20, next, next 20. Right? We're going to replace the list with the current list of 20 that we're seeing, 20 at a time. Okay. And if you click previous, it's going to go backwards. So we're going to see the previous 20 that we just saw, previous 20, previous 20. Okay. I think there's like 1,000 or something Pokemon. So you should be able to click next for quite a while. And I want you to think of some of the edge cases here in this case, where, maybe do we click previous if we're already at the start of the list? Can we click next if we're at the end of the list? Things like that. Okay. Then import it into your main and replace the app with it and test that it works in your browser. You can press the previous and the next to see the network requests go out to the network tab and actually watch them go out and make sure the responses come back and they're what you expect. And that you see the new names re-render in the DOM as you're going back and forth using these buttons. Now you can use the next and previous pages from the responses to make this easier. So take a look at the actual response in the documentation and the actual network tab that comes back. There's a harder but more robust way to do this, which is actually keeping track manually of what are the limit and the offset. But in this case, the API makes it really easy for us to not have to do that. So you could try both ways if you want a bit of a challenge, but I would encourage you to use what comes back from the API to make things a bit simpler. All right, so give that a shot, definitely a challenging one, and then we will go through it together. Oof, okay, so new folder, exercise 3. So I'm getting sweaty in here, holy moly. It's a lot of coding at one time, one session. We're over an hour in, hopefully you're still with me. So let's create a new file here, Pokemon.jsx, and we'll do function Pokemon, export default Pokemon. Oops, there we go. Okay, so let's import this just to make sure we actually have this working. So I'm going to comment this out. I'm going to come over here. I'm going to say import Pokemon from exercise 3 Pokemon.jsx. Okay, and there we go. And if I switch back to my browser, we should see absolutely nothing in the DOM, which is what we expect because there is nothing being returned. So that's great. Okay, cool. Now, let's take a look at this Pokemon API. So I'm going to switch back here to Pokemon API, and I'm going to go to this documentation up here in the top right, API v2. And there's a whole bunch of nice stuff here that talks about how this works. I mentioned that we want to look at the pagination link, so I'm going to click on that. It's going to take me down here. So resource list pagination, calling an API endpoint without a resource ID will return a pagina list of, or a name will return a pagina list of available resources for that API. That is a confusing sentence. I don't actually know what that means. By default, a list page will contain up to 20 resources. If you would like to change this, just add a limit query parameter to the get request. Example limit equals 60. You can use offset to move to the next page. Example limit is 60, offset equals 60. And here's an example of what that looks like. So Pokemon API /v2, and then the endpoint is this. I think they have an example down here. So yeah, right here they're using the ability API. We're going to be using the Pokemon API. So hopefully you caught that little tidbit as well. But we see that we get back a count. So this is the amount of items in that total in that list. And we're paginating this. So we're getting this back pages at a time. And we can specify how many we want back and then how far offset from the start we are. So this is saying I want 20, but after the first 20. Okay, that's how to read this. So a lot of APIs use this kind of format so that you can easily fetch different pages no matter how far they are from the beginning and as many as you like. Sometimes it gives you a limit. Okay. So we can see here that there's a count, there's a next key, and there's a previous key. And it looks like previous is null, which is quite nice. We can actually use that to conditionally render things if there's no previous or if there's no next. And then we have a list of results. Okay, so that's pretty good. So I'm gonna copy this, and I'm gonna see how I can work with this. So I'm gonna say switch back to Pokemon. I'll say const URL is equal to this and make sure that is in quotes. Okay, so I'm going to grab 20 and I'm going to start at offset is 0 to start. Okay. All right. So how is this going to work? Well, let me think for a second. I want to list, as soon as this component loads up, the first 20. And then after that, I want to make it so that when you click the next or the previous button, we're going to fetch either the next or the previous 20, depending on which button you click. So how do we get that first part working? How do we display the first 20 no matter what? Well, I'm going to make a fetch request to this one because that is limit 20, which is get 20, offset 0 starting at the beginning. So I'm going to do a use effect when this component mounts. So I'm going to say use effect, and I'm going to say use effect. I'm going to make sure that this runs when the component mounts. And I'm going to make a fetch request to this URL. In fact, I can probably put this URL in here for now because that's exactly what's going to is only going to be used here, which we'll see shortly. And then I'm going to do a .then. I'm going to get back that response. For now, I'm just going to assume it's there. I won't deal with the error conditions. I'll be a bit quicker with this just so that we can deal with that later if you want to. Response.json. Then I'm going to set the current page. So I'm going to say const. I need some state here. So I'm going to say use state. I'm going to say Pokemon page, set Pokemon page equals to use state. I'll start it off as null. Then I'm going to get back some JSON, and I'll say set Pokemon page to be the JSON. Okay. And then what I'll do is I will hopefully, once that changes, I'll just return in here. For now, I'll just return an H1. I'll just say Pokemon list. And I'll do a console.log of my Pokemon page. All right, so I'll switch back to my Pokemon app here. I'll refresh the page. And I get Pokemon lists listed out, so that's nice. I'll go to my console, and we can see that it starts off as null, and then we get back this response. So that's pretty cool. So let's open that up. I'm searching for abilities in this case. So excuse me, I'm going to change that. I have a next, I have a previous, and I have some results. So look at all those abilities: Stench, Drizzle, Speed Boost. Wow, some cool names in there. But I don't want abilities. I want Pokemon. So I'm going to switch that. I'm going to switch this to Pokemon, not abilities. And I'm going to refresh the page here. And now we get 1,281 results. And limit is 2. I don't know where that's coming from. I'll have to probably look at that. Or it's 20. Oh, it's just off the screen. Okay, that's what it was. Limit is 20. And the results, look at that. So we have the a list of results. And in that list of results, we have an object in each of those. And each object has a name and a URL. Okay, so let's think about this. We're getting back a list of results. And that we can map through and return a bunch of JSX that has Pokemon names in it based on how many are in that array. So let's see if we can get that working. I'm going to do this, and I'm going to do this, and I'm going to put my Pokemon list up here, and make sure this is in the right spot right there. And now I'm going to map over this list. So I'm going to do Pokemon page dot results, Pokemon page dot results, right? Because that's what's coming back right here, dot results. And I need to make sure Pokemon page is not null. So I'm going to do question mark dot results. And again, this is not ideal to do in the JSX. I'm just going to do it for now, just so that we can eventually refactor it later. Dot map, I'm going to get each Pokemon. And for each Pokemon, I want to return a p tag. And in that p tag, I want to put the Pokemon dot name. Okay, so I'm saying go through every single result once Pokemon page is not null, and give me a list of p tags where each p tag is that Pokemon object's name. Save that, switch back here, and look at that. We get back that list of Pokemon names on our screen. Okay, and you can see that matches exactly what we see over here in the same order. All right, probably need to zoom out a little bit on that. That's pretty long. You know what I'll do is I'll instead of fetching so many at a time, I'll fetch 5 at a time, so we can actually see that on my screen, and you can actually you can imagine that's going to be a bit different for each of these. So it's saying that we need a key prop for each of these. I mentioned in the previous video, this is something that we would need to make sure that we put as a attribute here, so React can tell the difference between different nodes in here in the virtual DOM. We don't have an ID for each of these, so I'm just going to say that the key is the name because each name is unique, and then that error is going to go away. Okay, notice that I didn't make up that key. That's something that should come back from the API, and it should be unique for each specific node. Okay, so let's add these previous and next buttons and see what we can do. So I'm going to add 2 buttons below this. So I'm going to say button, and this is going to say previous, and this is going to say next. And let me save that and switch back here. There we go. Look at that, looking pretty good. And then I'm going to say on click. Yeah, I'll just call this previous, and I'll just abbreviate it, and I'll say on click, probably has a better name. Not on can play. What is that? Nope, on click. This is next, and I'll create those functions up here. So I'll say function previous, and I'll say function next. Okay, so that's pretty good. So let's think about this. So the first part is done, right? We have it so that when this page loads up, let me refresh this page. Page loads up, we have our list of Pokemon, and now we can click next and previous to go back and forth through that list. So we have a bit of an issue here because we're at the start of the list, and it doesn't really make sense to go previous when we're at the start unless we're doing wrapping around. So we probably should not show previous until you actually go forward. So we probably should fix that. And we should show next. So now comes the tricky part. What are we going to do with these buttons, right? How do we know what to do when you click this button? Well, let's look at this response. We have this response. We looked at the results. We're already mapping through those, right? These are the 1, 2, 3, 4, 5. If you have 20, that's fine. It doesn't actually matter in this case. We have the count. So is that useful for us? Not really. Not maybe unless we're manually tracking things. But we have a next, which is the URL to fetch the next set based on kind of what we already passed it. So you can see this is quite smart. This is saying I want 5, but after the first 5, right? So give me 5, but after the first 5. And if you were giving 20 at the time, this would be 20. And if you're giving 10, it'd be 10, etc., right? But notice also previous is null. So it's also smart enough to know that there isn't anything before this page. We're at the first page. There's no, like, if you have a book, you can't go to like, page -1. That would not exist, right? Or you'd get transported to another dimension or something. So we would want to make sure that we go forward in this list. If we click next and only show previous and go backwards if there is something before there. And the same is true for next, right? We don't want to go past the last page. It doesn't make sense to go past the last page of the book because that's the end of the book. Unless you can see the future and make more pages or something, then that would make sense. But in most cases, it wouldn't make sense to go past the last page. So we have to fix that. So we have a way to conditionally tell if there is a next and if there is a previous. So let's just first deal with the fact that we should conditionally render that. So I'll say, I'll come in here and I'll put these in JavaScript brackets like this. And I'll say if the Pokemon page .net, or in this case previous, exists, then render this button. Okay, and I'll do the same for this one, except this is .next. Then render this button. Okay, so if previous exists, then render this button. If next exists, render this button, and that'll be true for both of them if there is a previous and next, and only for one or the other, vice versa, depending on for the start or the end of the page. Okay, and that's going to work because we're setting the page depending on that response that comes back. So if I switch back here, you'll see that, look at that. We don't have a previous button on page 1, right? Because there is null, which means that conditional render is false, which is pretty nice. So that works quite nicely. So we're pretty close actually to being done. We need a way to make it so when we click on these buttons, we fetch that next page. So we kind of have the scaffolding for that ready, right? We have on click is previous and on click is next. So let's do previous first. So for previous, what are we fetching? Well, let's think about this. We have the state already set for Pokemon page, which is this object right here. So if I click previous, that means that previous exists and I can fetch previous. If I click next, then next exists and I can fetch this next. So I'm just going to fetch that value and set that to be the new page. So let me actually do next because that's the one that exists. So I'll say fetch. I'm going to do Pokemon page dot and I'm going to do next, right? Which is this URL. I'm going to fetch that URL dynamically. Once I have that, I say dot then. I'm going to say response. I'm going to turn it into JSON. I'm going to, again, not check for errors. I encourage you to add error conditions here. And we're going to grab JSON. Once we have the JSON, very similar to what we did here, this is the exact same code, right? In fact, this is kind of problematic because we're repeating a lot of code here. So this is a good idea for refactoring. But let's just stick with it working for now. Then I'm going to set the current page to be that new JSON. Okay, so what I'm saying here in English is that once I have the first page, which is this one, and I click next, I'm going to make a request to this URL, which is given to me by the API. It's smart enough to actually format it correctly. You can see the offset query parameter and the limit query parameter are in there correctly. I'm going to then fetch that. I'm going to get that and set that to be the new state. And then that's going to have a new next and a new previous and new results. And that's automatically going to re-render in our DOM because we have our state set up to watch for results, which is pretty nice. And actually, that's going to also fix previous showing up because previous is not going to be null anymore. So let's test this out. I'm going to come back here and I'm going to save this. I'm going to come back to Chrome. I'm going to refresh the page. and I'm going to get an error. So what's the error? Cannot read properties of null reading previous. All right, so I have expected that. So let's take a look down here. Pokemon page.previous. So when we first render Pokemon page, it's null. So I'm just going to put an optionally chain right here. There are some other things we could do to test that, or we could do other types of conditional rendering. I'll just go with that. Okay, this is going to immediately evaluate to null as soon as this is null, and it's not going to bother checking that key. So I'm going to refresh the page again, and we get the first page of results: Bulbasaur, Ivysaur, Venusaur, Charmander, Charmeleon. And if I look at the results, that is exactly what we see over here: 0, 1, 2, 3, 4. And check this out. Okay, I have a next of that value, and previous is null. I'm going to click on next. Let's see what happens. 1, 2, 3. All right, so that's pretty cool. So a bunch of things happened there. Let's go through this one at a time. I got a new set of results. The previous button showed up, and I got my log here. So if I open that up, you can see that now next is populated. Previous is also populated. This is the new Pokemon page state, and we have that new set of results with those new Pokemon. And since previous is no longer null like it was up here, then what we're getting is this previous button to show up. And if we were to click on it, we haven't set this up yet, but this is the URL to fetch. If we click on next, now this is the URL to fetch. Notice that this is also updated. We're offsetting to 10 now instead of offsetting to 5. So that is pretty cool. Hopefully that one makes sense. I encourage you to really make sure that that part makes sense to you. In fact, I'm going to fix previous and then show you the network tab just so it really gets hammered in. So for previous, we're going to do the exact same thing. We're going to say fetch Pokemon page dot previous dot then. Again, lots of duplicate code here. Response.json dot then JSON set Pokemon page to be that JSON. Okay. Whenever you see this kind of duplicate code, almost the same, you probably want to think, should I refactor that into a function? Not always, but a lot of the time you do. All right. So that's pretty good. Let me refresh the page here. There's no previous. I'm going to click next. I get next. I'm going to click next again. I get a new set of Pokemon. I'm going to click previous. I get the previous Pokemon, previous, and I get the first set. And now I'm at the start of the list, and I can click next, next, etc., etc. Now I'm going to show you the network tab, and I'm going to clear this out, and I want to show you what happens. I'm going to actually first load this page. I'm going to click the next button. I'm going to see a request made to offset equals 5, limit equals 5. Okay, that response looks like this. You can see that there is a next for offset 10, limit 5. And then the previous is, as we'd expect, offset 0, limit 5. So if you think of the math for this, we are currently at offset 5, limit 5. So previous is offset 0, limit 5, and next is offset 10, limit 5, which kind of makes sense. So that makes sense. If I click next now, I'm going to be doing offset 10, limit 5, which is what we see. And if I click on that response, we'll see that the next now is offset 15, limit 5, and the previous has been updated to offset 5, limit 5. So we're a 5 on both ends, plus 5 and minus 5, depending on what our offset currently is right now in the state, which is 10 in this case. If I click on next one more time, we will see an offset for 15, and then we will get back that result. And if I click previous, we will go back 5 and we'll see the same result from previously, and now we will update it to the previous state that we had before. We're still making all these requests, which is why this is a bit problematic. So we probably would want to cache these or use a library to cache them for us. But that really essentially is the solution to this problem. There was a lot going on with this example. There definitely are many other solutions than the one I just showed you, as with all the other examples that we went through together. This is just one potential solution. There's a lot of refactoring to do in this potential solution as well. By no means is this great code. In fact, this is pretty bad code. As I mentioned, there's a lot of things that is duplicated in here. There are things that we could make it easier. So if we did have to update URLs or promises or buttons, we could probably do a better job with error handling. There's a lot of nice things we could do to make this a lot nicer. But the core point of this exercise was to actually fetch those pages and be able to go back and forth and understand what is happening. So hopefully that did come across. Oh boy. So that was quite a lot for this video. That's quite a long one, but I hope you enjoyed that set of exercises and it was valuable to you. This is such a core concept to understand when you're working with React and building your own applications in the real world. So I hope you liked this video. If you did, I'd love it if you could like the video and subscribe to the channel. If you do want to support the channel as well, I have a Patreon set up as well as YouTube memberships and super thanks. So you can show your support that way if you like and are able to. What we're going to do in the next video together is probably one of our final, at least core set of theories to go through for React before we can look into the projects to wrap up this course, which is this idea of custom hooks. And that's kind of what I was hinting at earlier when I mentioned caching. There are so many things that we probably have seen now working with these different hooks where you're probably thinking, wouldn't it be nice for me to be able to use that in other places, in other components without having to always keep typing it out again and again and again? And the answer is yes. And that's exactly what a custom hook is. And we're going to get into that in the next video together. So I can't wait to get to that and then get to the projects after that. I will see you in those videos. See you later.